Evan, so I have another video here since our time got cut kind of short today. I apologize for that, but I am going to go over this second quiz. So I went over I think your first attempt, and now I'm going to go over the second attempt. You're actually going to see some repeat questions here, and I'll just kind of touch base on them again with how those were solved. So remember in this first example, we were given 3 different plants, plant A in the table, plant B is the equation, and plant C on the graph. And it was asked that if the growth pattern continues, how much taller is the tallest plant than the shortest plant at 120 weeks of growth? And so we looked at plant A, where you could see right here at 120 weeks, plant A and B and C. So plant A is at 180, looks like it's in inches, and this is height. For plant B, we actually had to plug that 120 weeks in T for time. So we're going to do H equals 4/3 times 120. And that one gave us, let's see, let me do this one in my head, 483, 160 inches. And then in the table, we can see right here, this is the ordered pair that has 120 weeks for time, and so it's 360 inches. And so then again, the question was, what is or how much taller is the tallest plant than the shortest? So we needed to figure out all of their heights at 120 weeks. We see that C is the tallest, B is the shortest. 360 minus 160 is 200, which was the answer choice here. Question 3 was also a question that we went over earlier today, and this one is about milligrams. I don't know the scroll. Oh, it can't scroll. Milligrams of medicine you're going to give to a dog based on how much it weighs. So the dosage here depends on the weight of the dog. And that can kind of help you know which variable is going to be X and which one's going to be Y. However, if you look here, you can see that these are all set up so that the dosage is the dependent variable. It depends on the weight, so the weight's kind of like your X here. So when we have to find the constant of proportionality, remember, we do Y over X. In this case, though, it's dosage over weight. D over W. And so we use the situation that they give us in the story. 30-pound dog gets 3/5 of a milligram. And I think earlier today I did it with my calculator, and I changed 3/5 into a decimal and then divided it by 30 and got a decimal, and then I compared my answer to the 4 option choices here. If you want to do it using fractions, remember that in order to divide fractions, we do keep, change, and then flip or multiply by the reciprocal. And so 3 times 1 is 3, 5 times 30 is 150, and if we divide the top and the bottom by 3, we get 1/50th. So there's your constant of proportionality. Question 6, this was also one that took a lot. It took me just kind of a second to figure out what I needed to actually do. So we needed to find the constant of proportionality from this table because this is the weight on Earth and Mars. And then we also needed to find the information from the graph because this is the weight on Earth and the Moon. And then subtract the weight on Mars and the weight on Moon to see what the difference would be for a person who weighs, I think it was 240? Yeah. So the person weighs 240 on Earth. So what we were able to do from the graph was really easily tell, well, if you weigh 240 pounds on Earth, you're going to weigh 40 pounds on the Moon. It wasn't as easy to tell from this table, though, because this table doesn't go up to 240 pounds. I noticed from 90 to 120, that jumped 30 pounds, then it jumped 40 pounds, so I couldn't really find a pattern. However, there would have been a little bit faster trick here, noticing that if we double 240 pounds, we would also double the weight on Mars, so 48 times 2 is 96. We ended up getting there anyway. Remember, if you do y divided by x, so like 36 divided by 90, we could do it here. You could do it here, 48 divided by 120, or 64 divided by 160. And all of those give us the exact same constant of proportionality. Sorry, my son and my dog are being wild. But if you take 36 divided by 90, you do get 0.4. So we figured out the constant of proportionality. So you can find the weight on Mars if you take 0.4 of your weight on Earth. We're going to get 96. I'm just going to show you again with the equation, 0.4 times 240, and that is 96. And so now what we're focusing on is the 96 pounds you weigh on Mars and the 40 pounds you weigh on the moon if you weigh 240 pounds on Earth, and we subtract, those two numbers to find that difference, and we got 56. Okay, then I think 8, 9, and 10 might have been different. So this one asks, which representation has a constant of variation of negative 2.5? So what this means, your constant of variation is the y value when x is 1. So if we look here, oh, and of course, I always write too high and then I can't see. So I gotta scroll. Oh, I gotta scroll even farther. Okay, so let's start at the table, or the graph, If I go over to 1 and down to 2.5, that would be right here. And you can see the graph does not go through that point, so that doesn't work. Plus, this is not a proportional relationship. That graph has to go through the origin. That graph does not pass through the origin, so it is not constant variation or proportional. Or direct variation, And letter C is the same situation. In equations of direct variation, you won't be adding anything to the back. It's just y equals kx. This does show that. It looks like your constant of proportionality is negative 2.5, but again, you can't add or subtract anything in those equations. So now we're just checking these tables. And you can go all the way down and check them. Again, you're just doing y divided by x. So I'm going to grab my calculator. I'm going to start right here with this ordered pair, and I'm going to do it kind of quickly. Actually, I'm going to do it so quickly. A negative divided by a negative is a positive, right? We're looking for a negative variation, a constant of variation, so all of these are going to give you a positive. So table A doesn't work. Basically, process of elimination, it's got to be B. However, let's just actually prove it. So taking negative 10 divided by 4, taking negative 15 dividing it by 6, taking negative 20 dividing it by 8, and negative 25 and dividing it by 10. If you grab a calculator, every single one of those gives you negative 2.5. So that one should have been table B. Yes. Question 9, this is another new one. We didn't see this one earlier. Caleb made the table below to show the number of hours he works and the amounts he earns over a 4-week period, which describes whether the relationship between the earnings and the number of hours represents a direct variation. So in order for it to be direct variation, two things have to happen. One, 0, 0 has to make sense in this situation. If Caleb works 0 hours, he is going to earn $0. So that makes sense there. And then you just have to check all the way down the table. Now, for most of us, we make an amount of money per hour. And so that is a direct variation, but we should verify. So again, y over x. This bottom row in a table is always the y, the top row is always the x. So we're doing 140 divided by 12. We're doing 170 divided by 15, 200 divided by 18, 230 divided by 21. So we're checking all 4 of those just to make sure. 140 divided by 12, it's 11.6 repeating. 200 divided by 18. Okay, that's not 11.6 repeating. 170 divided by 15, not 11.6 repeating. 2/3, okay, so this is actually not direct variation because these ratios are not all equivalent. He earns 20 more than 10 times the number of hours he works each week, so the earnings vary directly with the hours. Okay, so 20 more than, if we take 10 times the number of hours you work and 20 more than that, So this is that piece I was sharing with you a little bit ago. Direct variation equations will never have addition or subtraction on them. It's just y equals kx. This would indicate that if he didn't work any hours, he made $20, and that's not going to make sense. The earnings increase by 30 for every increase of 3 hours, so the earnings vary directly with the hour. They don't vary. The ratio of earnings to hours are not the same each week, so the earnings do not vary directly. Yeah, that's that third option choice. And we figured that out by checking all those ratios from the table. Table shows the number of color pages. Oh, we did this one, I think. This one you just had it backwards. You had x over y here. And remember that to find the constant of variation, you always take the y value and divide it by the x. And again, you can take any ordered pair from the table. If I do 9 divided by 6, and then I reduce that fraction, 9 divided by 3 is 3, 6 divided by 3 is 2. I can do the same thing with 12/8. Divide the top and the bottom by 4, and I'm going to get 3 halves again. Same thing with 27 over 18. So it is 3 halves, it's always y over x. So again, I wanted to take a second to kind of go over this one too, since we were cut short today, and now I'm not going to see you until Thursday, or talk to you till Thursday, give you an opportunity to retake it and then continue on. Let me know if you have any questions.